Hi, this is Tag again. Today I want to talk a bit about the ASRock 4CoreDual-SATA2 and also other variants like the ASRock 775 VSDA and because they're all basically the same board. Now, what's so special about this board is that it has DDR1 and it has AGP and supports relatively modern CPUs. This makes it, as far as I know, the fastest DDR1 board and either the fastest or second fastest AGP board. There's a AMD board that supports Vmem 2s, which is also up there. Now, first things first, I like to replace caps on everything. So let's get one that I have modded and show you what I do to them. Here we are. Now, as you can see, I replaced basically all the caps on here. Just with not even new ones, just regular old aluminum polymers. Even those are better than the electrolytics on the stock board. But that's not really what I'm here to talk about. Cap mods, everybody knows that basically. Just throw more caps on, more modern caps on stuff. What I want to talk about is voltmods and some other stuff on these boards. Now let's get started with the CPU side. So this is the CPU VRM. Come on. There we are. Now this yellow wire here goes to this potentiometer. That's in my case 50 kilo ohms. Can't see that. You can use anything between 20 kilo ohms and 50. Now the trick here is that you have to remove, I need some pointy thingy, remove this little resistor here. That's a 0 ohm resistor basically between the feedback pin of this voltage controller and the Vcore's plane on the CPU. Now, as you can see, stock board has it on there. That's really all you have to do here. The potentiometer is between this pin and ground. Next, memory. Oh, I should mention measuring points for CPU. I just use any of the Vcore caps on the back, as you can see. There is the white wire of the, come on, focus. There we go, white wire of the voltmeter. Vmem. That's really bad on this board. I made it way too compact. There is, I'm going to show all of the voltmods later with good photos and paint, so you can actually understand them if you don't see anything. Just like you don't. There is one leg of the potentiometer at the bottom of this one capacitor here, and the other one is on ground. With this one you can use, well, I use 5 kilo ohms, but you can also use 10 kilo ohms or 20 kilo ohms potentiometers. Just adjust them accordingly. The higher the resistance of the potentiometer, the well, the finer you can adjust it, but also, well, you are not going to get as good performance basically at the higher voltages. You have more fine adjustment at lower voltages, but once you get to a certain point you have more change per turn basically. Now next thing is, actually two. There is the volt mod for the AGP rail, which also supplies the North Bridge. That's the bottom one here. And the top one is VTT CPU voltage. With those you replace two resistors. Let me show you. There is stock board. Come on. Again, I'm going to show this afterwards in a way that you can actually see, because I don't think this wants to focus. Come on. There we go. Now you remove this resistor all the way to the right here, and the second resistor in this long row this one. The bottom one is Northbridge voltage. The stock resistor value is 10 kilo ohms, so I would replace it with either 10 kilo ohm potentiometer or 20 kilo ohms set to 10 kilo ohms. The VTT one is 15 kilo ohms, so use 20 kilo ohms set to 15. So you have the same values as stock, so don't get too high voltage on the first boot. Now these potentiometers are between the respective pins. The one's closer to this LM324 here and ground. I just used the capacitor ground here. That's it for voltmods. Let me quickly show you measuring points for Northbridge voltage. AGP there is a point called VT4 here. That's if you want to use the top side, and there is also a point called VT2 here. This is for VTT, also top side. If you want on bottom, you can use the upper leg of either of those capacitors for VTT, or either of those three capacitors for VAGP. I use the bottom. Let me show you. You just have a Molex connector soldered to the 2 points, 2 grounds to the chassis grounds of the audio, and nice little Molex sticking up here. For CPU and memory, I have voltmeters. You can also put 4 voltmeters on the board so it lights up nicely. Basically Christmas tree board at that point. Now, next thing. This board needs a BSEL mod to run high FSBs with 200 stock FSB CPU. So your E50-800 Pentiums, basically. That's the best chip you can use dual core wise on that board, unless you have a E6500K, but they are pretty rare and they don't clock that well usually. So what you would usually do with BSEL mod is just short 2 pads on the CPU or insulate pads on the CPU. I did that before, but I did some probing around on the board and I figured out the easier way. I just soldered one little wire on the top leg of this resistor here to the right, closest to the BIOS battery. And that little wire leads to just a jumper, and that jumper is, you see, 3 pins. The bottom one here is, or right one in this case, isn't connected to anything, so it's the parking position for the jumper. The middle one is connected to the resistor down here, and the left one is connected to ground. So all this does is ground out the BSL1 pin of the CPU, because that's basically all you need. I'm going to show you later on the computer why that is the case. Just one quick thing, the ground I used for this, let me show you on the board that has it. Come on, focus. It's just this pad of this unpopulated IC here. This is the ground. One quick mention. I know that some people did GTLRef Mod. Basically, you have on dual cores you have 2 GTL voltages on the socket. On quad cores you have 4. However, quad cores have their internal reference, so you can run them with 2, which ASRock did. GTL2 and GTL3, now this is 2 and the upper one is 3, anyways, are not connected on this board. Now, according to some people, connecting them, the GTL2 to GTL0 and GTL3 to GTL1 helps with FSB on quad cores. However, I couldn't confirm this so far. I tested this board here without and with the GTLs, and without the GTLs was the same as GTL0 0 connected to GTL3 and GTL1 connected to GTL2. And connected the other way, so GTL0 to GTL2 and GTL1 to GTL3 was even worse than stock. So I can't confirm this, but according to TerraRaptor on HW Bot, it helps on some CPUs. You can try yourself. If I find out something special use cases that it only works for some CPUs or something like that, I will make an update video on this for sure. So let's zoom out. I think that's about it for the hardware side of things. I will show you some nice screenshots and some nice paints now, and basically make a guide on the computer for the Voltmods and the BSEL mod as well, just in case you didn't see it on the video now, because I'm not sure how good the quality is and how good the focus is and stuff like that. So see you in a bit.
Okay, here we are again, this time in a way that you definitely will be able to see how I do the Voltmods. Now let's start off with Vcore. This is the 0 ohm resistor I meant that you had to remove. It's just a resistor between the feedback pin from the voltage controller and the other side here, the 6 trace here, is directly to Vcore. Now let's draw the mod here. This is the pad you want to connect your voltage, not voltage, variable resistor to. So let's take that little thing. And the other side straight to ground. Now for values, I use 50 kilo ohms, but you can use 20. Now let's do, say, 20 to 50 kilo ohms. Just keep in mind, with 20 kilo ohms, the lowest voltage you can set is pretty high already, but should be below 1.5 volts with most CPUs, so still air coolable. If you want to be safe, probably use 50 kilo ohms. As for grounds, you can use the screw hole here or any capacitor ground. Now personally, I put the potentiometer right here and solder one leg directly to the screw hole and use the middle leg and connect it to this pin here. You can do it as you want, put it anywhere on the board basically, but that's the easiest way I found to do this. Now let's continue to memory. Memory is here. Memory. So in a bit. There we go. Now here you don't need to remove anything, so just keep in mind this pad and this pad here are your feedback pin. I like to connect stuff to this pad, but you can use either one, just like this. And again, variable resistor. Actually, that's not smart to do it like that. Let's go over here. Up. Variable resistor to ground. Same with these voltmods. Ground. Now, for values, I use 5 kilo ohms, which means that the minimum voltage with DDR2 is like 2.2, and with DDR1 it's probably, I don't know, 3.5 or something. I don't particularly care on win bonds on those, and they pretty much run fine at any voltage you give them. Again, I would say 5 kilo ohms to 20 kilo ohm. It's fine to use here. Just start out with the highest value, you parallel it, so should be fine. For grounds, this pad here is a ground. Obviously this screw hole has ground, and I personally use this pad here. Now if you measure here without memory installed, it's not gonna measure ground, but once you have memory installed, it's just a ground. So I use that one and like put it right here, so I can directly connect to this pad here and this pad here without using any extra wire. Again, do as you prefer. Just any ground will do. Any amount of wire. It's not like high frequency stuff, so you can run wires basically across the whole board and it's just fine. Also, measurement point here on the top of the board, on the bottom just use any of the caps for Vmem. Now let's move on to Vagp and Vtt. There we are. Now with this one again, you have to remove two resistors. This one here and this one here. Those are gone. And the pads you want to connect your wires to are the inner pads, so the pads facing the LM324. These two. That's a bit big. Let's make that smaller. These two. Let's start off with Vagp. That's the bottom one. Again, good old variable resistor. And ground on the other side. Again, the resistor you remove is 10 kilo ohms, so you want to replace it with, I would say, a 10 to 20 kilo ohm variable resistor. Set it, which is it's kind of important, 10 kilo ohms at start, just to be safe, so you can see how it changes. So not max value as you usually do with your voltmods. Just set it to 10 kilo ohms, check with your multimeter, put it on there. Same with the other one. This one, however, is a 15 kilo ohm resistor remove. So resistor and your ground on the other side. This one I would just use a 20 kilo ohm. 20 kilo ohm. Set 15 kilo ohms. Start off with. That gives you plenty of headroom. You don't need to raise it because I don't think there's any point in lowering VTT. With this one you might want to use the 20 to run below stock AGB voltage, but also then again I don't think there's any real gain here with the via chipset. So probably just use a 10 if you have it. For grounds, you can grab this ground or that ground. I use that one and just put the two resistors like right here next to each other. Connect both grounds to the ground. Well, two outer pins to the ground and the middle pins to their respective pads here. That's just leave those two here. That's how I put those on here. Also this one is ground, but I don't use this one for a reason you will see soon, once we get to BSL, which we're going to do now. BSEL Mod. Here is our clock gen. For BSEL Mod, just keep in mind, these two pads here on these resistors are BSL 1. These two are BSL 0. Now what does this mean? Let's have a quick look at the data sheet for 775 BSL. Now those are your BSL bits or pins, or however you want to put it. They are physical pins in the socket. BSL 0, as you can see here, it's low at 400, 300, basically all of them. BSL 1 is the one we really care about, because what we want to do is run our 200 FSP CPUs at 266, so the overclocking headroom increases. 200 FSP CPUs basically Pentium E50 200 to 5800. Those are kind of relevant because they have enough multiplier to be clocked pretty high on this board, even though it doesn't clock FSP that well. Now, as you can see, the only difference here is this BSL 1 bit, and all we have to do is set it low, so pull it to ground. Now, if you think about it, if going from 200 to 266 BSL improves overclocking headroom, then you may ask, why don't we go from 266 to 333? Now let me show you why. This is our datasheet of our clock gen on that board. And these two are, come on, these two are our BSL pins. There's only two of them here, 0 and 1. And ASRock didn't even connect the BSL2 pin of the socket to anything. So this is completely irrelevant what we have here. It would be great to have a 333 option, because I'm pretty sure it would improve FSP significantly. But unfortunately we don't have that option, so we can ignore that one, and we can ignore that one. So what does that mean for our mod? Well, basically, you have your BSL1 here, and not a resistor. Just put a switch, GD swatchity, to ground. That's the jumper I showed you. You can also use just a normal switch, like a small switch. Just short out this pin, that's it. You don't need more. You can then run the 200 FSP CPUs at native by removing the jumper, or at 266 by putting the jumper on. It worked fine for me. I already tested it. E5200 runs at 3.3 GHz stock. So that's actually the other great thing about this. Well, great depending on how you see it. The CPUs boot up at a higher frequency even before setting anything in BIOS. So the upside of it is that even if you're running stock FSP, let's say, you have improved performance. The downside is, of course, that it might be unstable if you have a really terrible sample or set Vcore way too low. So just keep that in mind when doing this. Now let's quickly take a look at GTLRefs. Now, personally, I couldn't see any gains from this. Now this is our GTLRef 0, and according to what I heard from TerraRaptor, you should connect it to GTLRef 2, which is down here. So run a wire down here and take your GTLRef 1 to GTLRef 3, which is over there. Now GTLRef 0 and GTLRef 1 are actually powered on the board. GTLRef 2 and GTLRef 3 are not connected to anything. Wait, let me move this a bit so you can see the full socket. What this means is that in theory the CPU has to use its internal reference, which in theory might be worse. Now, however, for me, it worked better without any mods than with GTLRef 0 and 2 connected, and it worked the same as when I connected GTLRef 0 to GTLRef 3 and GTLRef 1 to GTLRef 2. Now this odd pairing worked the same as nothing. I don't know why, but that's how it turned out for me. Again, this mod, I can't say much about it. I just wanted to show you how to do it so you can try it out for yourself. There is very little chance to ruining anything. Well, there's definitely no chance of ruining anything if you do the mod properly, but you're soldering on the bottom of the socket, so just make sure you don't short any pins on there. Then you're perfectly fine, and you can just try it yourself and see if it does anything for you. Let's go back to a nice little painty. I hope this helped you, and I hope you will be able to get like 300 FSP and some nice scores out of those boards.